In this video lesson, we will be discussing the following concepts: base levels of erosion, ungraded river, the concept of a graded river, and dynamic equilibrium. A base level of erosion is the lowest point to which a river can erode the land. In theory, the river is going to try and completely flatten the land over which it flows. The lowest point to which the river can erode the land is sea level. Therefore, the sea or the ocean is known as a permanent base level. However, along the course of the river, there might be instances where the river encounters certain features that are going to slow down or stop erosion for a short period of time. Those features along the course of the river that slow down or stop erosion for a short period of time are called temporary base levels. Examples would be dams and lakes and waterfalls. In a dam, for example, the water flows into the dam, the water is forced to slow down, and therefore it loses its ability to erode. So important to remember that a base level of erosion is the lowest point to which a river is going to attempt to erode the land. The only permanent base level is the sea or the ocean. However, the river will encounter temporary base levels along its course, and these will for a short period of time or temporarily slow down the rate of erosion. Dams, lakes, waterfalls are examples of temporary base levels. An ungraded river has an ungraded longitudinal profile. Such a longitudinal profile, showing the side view of the river from start to finish, is uneven. The profile is uneven because of the presence of temporary base levels. In the diagram below, the temporary base level would be the lake, which for a short period of time slows down erosion rates within this river. An ungraded river displays an ungraded longitudinal profile because there is an imbalance between erosion rates in the upper course of the river and deposition rates in the lower course of the river. So important to remember that a river is said to be ungraded when it has an ungraded profile or an ungraded longitudinal profile. Such an ungraded profile is uneven. It shows temporary base levels, and in theory a river is ungraded and displays an ungraded profile when there is an imbalance between erosion rates and deposition rates. A graded river, however, has a smooth concave longitudinal profile. A graded longitudinal profile shows no temporary base levels along its course, and in theory a river will achieve a graded profile, or a river is said to be graded when there is a balance or an equilibrium between erosion and deposition rates. If an ungraded river is uneven, a graded river is smooth and concave. If an ungraded river has temporary base levels, a graded river has no temporary base levels. For an ungraded river, there is an imbalance between erosion and deposition rates. However, a graded river achieves a graded longitudinal profile because there is a balance or an equilibrium between erosion rates and deposition rates along the course of the river. What follows is a question from Geography Paper 1 of June 2022. Question 2.3 says to refer to the sketches showing the profile and grading of a river, refer to sketch A. The first question requires the definition of a longitudinal profile. A longitudinal profile is a side view of the river from start to finish. Two characteristics of the longitudinal profile in sketch A. The profile is smooth. The profile has a concave shape. The upper course is steep. The lower course is more gentle. You can even mention the fact that there are no temporary base levels along the course of the river. Question 2.3.3. Does sketch A represent a graded or an ungraded river? Sketch A represents a graded river, and the reason for choosing the word graded is the fact that the river in sketch A has a smooth concave shape and that there are no temporary base levels along its course. Refer to sketches B and C. 2.3.5. Identify a temporary and a permanent base level of erosion in sketch B. So in sketch B, the temporary base level is the waterfall and the permanent base level is the sea. 2.3.6 says to describe the processes that the river in sketches B and C would undergo to reach a graded state. So this question requires you to have an understanding of what needs to happen to the rivers B and C in order for their profiles to look like the profile in sketch A. In other words, how does this river go from an ungraded profile to a graded profile? Important to remember that the word processes merely refers to either erosion and deposition. Earlier on, I alluded to the concept of dynamic equilibrium, and this is exactly what this question is looking at. There are three areas in which you need to focus. The first one would be to focus on the waterfall in sketch B. That waterfall needs to be eroded. Therefore, in the upper course, the rates of erosion need to increase in order for the waterfall to be eroded. In sketch C, deposition needs to increase in the lower course. The sediments for the lower course will come from the erosion that has taken place in the upper course. Once erosion and deposition are in balance, the river would then achieve a graded state. So the first thing to say is that there needs to be an equilibrium or a balance between erosion and deposition rates in the river. Secondly, in the upper course, erosion needs to increase so that the waterfall can be removed in order for the profile to become smoother. However, in the lower course, all the sediments that were eroded in the upper course will now be deposited in the lower course, filling in the gap, therefore allowing this river to go from an ungraded state to one that shows a graded longitudinal profile.